Today's lesson is 3.2, Solve Linear Systems Algebraically. Graphing to solve system equations has some problems. Can you guess some? Graphing can be inaccurate, and it can be hard to graph sometimes. So perhaps there's a better way. We can solve algebraically. Today we're going to learn two methods. The first method is substitution. Step 1, solve one equation for one variable. Then, use that expression to replace that variable in the other equation. Next, solve the new equation. Then substitute your answer back into the first equation to finally solve for the second variable. Here's our first example. Notice the first equation is y equals. That means y is the same thing as the x plus 2. Since y is the same as x plus 2, I can replace the y in the second equation with x plus 2. Simplify. 2x plus x is 3x. Solve for x, so we'll subtract 2 and divide by 3, so x is 2. Now that we know x is 2, I can substitute that into the first equation, the y equals x plus 2. So since x is 2, replace x with 2. So y is 4, and our solution is 2, 4. Next example doesn't have any equations solved for a variable. But notice, the second equation has x all by itself. So it would be easy to solve for x. Subtract the 4y and you end up with x equals negative 4y minus 4. So x is the same thing as negative 4y minus 4. So if I take the first equation, the other equation, I can replace x with negative 4y minus 4. Simplify it by distributing the 3 to make negative 12y minus 12. Combine like terms, so negative 12y plus 2y is negative 10y. Add the 12 to solve for y, and divide by the negative 10. So we get y is negative 2. Now that I know y is negative 2, I can fill it into the x equals negative 4y minus 4 equation. So I'll take that equation and replace y with negative 2. So x is 8 minus 4, or 4. So our answer, xy, is 4, negative 2. The other algebraic method is elimination. First of all, line up the equations into columns. So you have the x's in a column, the pluses, then the y's, then the equal signs, and then the constants. Multiply one or both equations by numbers so that one variable has the same coefficient but opposite sign. Then you add the equations. Always set it up so you add the equations and one of the variables should disappear. And again, it's only if you do step 2 correctly, so that you have one of the variables with the same coefficient but opposite signs. So when they add, you get 0 of that variable. Solve your resulting equation, and then substitute the value you got into one of the original equations and solve. Here's our first example. Notice the y. It'd be easy to change the y in the second equation into 3y. So I'm going to multiply the second equation by -3 to give us 3y. That way we'll have negative 3y in the first equation and positive 3y in the second equation. Let's rewrite our system now. That's our first equation. Here's the second equation after I've multiplied by -3. If I add the equations together, we'll get -7x, 0y's, and it equals 7. Divide by the divide by the -7 to solve for x, and x is -1. Now that I know x, I can substitute that into one of the original equations. For example, the first equation. Replace the x with -1. So we have -2 minus 3y equals -14. Solve for y by adding 2 and dividing by -3. So our solution is -1, 4. Let's try another example. This time, I think it might be easier to get rid of x. If I multiply the top equation by 2 and the bottom equation by 3, we'll get 6x on top and -6x on the bottom. So if I rewrite my system, we'll get 6x plus 22y equals 8, so I multiply by 2. And then the second equation will be -6x minus 18y equals 0. I want to add these, and when I add, I'll get 0x, 4y, and 8. Divide by the 4 to solve for y, and y is 2. Now substitute that back into one of the original equations. For example, this time I'm going to use the second equation, but it does not matter which one you use. I'm going to replace the y with 2. So I have -2x minus 12 equals 0. Solve for x by adding the 12 and dividing by -2. So our solution is xy, -6, 2. Remember, we had several different options for the number of solutions. If both variables disappear after you substitute or combine, and you get a true statement like 2 equals 2, that means there are infinitely many solutions and you have the same line. If you get a false statement like 2 equals 5, there are no solutions and you have parallel lines. So, in summary, when should we graph? Just to get a general picture and get an estimate. But it's easier to use the algebraic methods. So when should we use substitution? Only when one of the coefficients is 1, or one of the equations is already solved for a variable. When should we use elimination? All other times, or when none of the coefficients is 1. I personally like to use elimination most of the time. And here is your assignment.